Hi everyone, we're doing lesson 7.2 today, double angle formulas. When addition formulas for sine, cosine, and tangent are used to generate some frequently used trigonometric relations. Recall from last lecture, sine of A plus B equals to sine A times cos B plus cos A times sine B. Let's suppose A equals to B. And let's use another variable so we don't get confused. Let's say that A equals B equals to X. That will give us the double angle formula for sine. So on the left side, that would be sine of x plus x. That's going to be sine of 2x. And on the right side, it will be sine x times cos x plus cos x times sine x, which will be the same thing as 2 times sine x times cos x. The double angle formula for cosine can be derived the same way, only there's actually 3 of them. So first we have cos of 2x equals to cos squared x minus sine squared x. Recall that cos squared x plus sine squared x equals to 1. Therefore, sine squared x is equal to 1 minus cos squared x. And if we plug that into this equation, that will give us the second equation of cos 2x equals 2 cos squared x minus 1. And if we plug cos squared x equals 1 minus sine squared x, that will give us the third equation of cos 2x equals to 1 minus 2 sine squared x. Double angle formula for tangent is tan of 2x equals to 2 tan x over 1 minus tan 2x. So let's take a look at example 1 from your learning resources. If cos A equals to 2 over 3, find the value of cos 4A. In step 1, we have to express cos 4A in terms of trigonometric functions of A. This is accomplished by applying the double angle formula for cosine twice. So first we have to write cos of 4A in terms of the double angle formula. It's the same thing as cos of 2 times 2A. Step 2, we can solve. Recall that cos of 2x equals to 2 cos squared x minus 1. In this case, our x will be 2a. So if we plug that back into this equation, we will get 2 cos squared 2a minus 1. We apply the double angle formula again inside this bracket. And that will give us 2 times cos squared a minus 1 squared minus 1. In the original question, it says that cos A equals to 2 over 3. So we plug that back into the question, and that's going to give us 2 over 3 squared because it's cosine squared. If we work all the algebra out, that's going to give us negative 79 over 81. Let's take a look at example 2 from your learning resources. Evaluate sine of pi over 8. So when we approach this question, we want to think of an equation that has sine over 8 in it. We're going to start out something a little different. So in step 1, we say that cos of pi over 4 equals to cos 2 of pi over 8. Because the 2 and 8 can cancel, and that will give us cos of pi over 4. We do this because we want this pi over 8, and later you'll see why. In step 2, we apply the double angle formula. That's going to give us cos of pi over 4 equals to 1 minus 2 sine squared pi over 8. So by now you might have noticed this is why we started with cos of pi over 4. So right now we have sine squared of pi over 8. But we actually want sine of pi over 8. So in step 3, we solve for sine of pi over 8. We rearrange the equation that will give us sine squared pi over 8 equals to 1 minus cos pi over 4 over 2. In step 2, since sine pi over 4 is in the first quadrant, therefore the answer is a positive number. Cosine of pi over 4 equals to 1 over square root of 2. And then we take square root on both sides of the equation to cancel out this exponent. And this is going to be the final answer that's shown on the slide. So this is the end of this lecture. Thank you guys for watching. Remember to check out your activity video and your assignment, as well as